Hi everyone, my name is Sergey. I want to discuss a browser feature that's there in the wild for 8 years, but nobody is really using it, and discuss some reasons why initial implementation was changed a lot after some time, and now it's in the version 3 state from version 1, and just discuss some bypasses of content security policy and how to make it work for you and without any bypasses and being sure that it does what it's supposed to do. So content security policy is basically a mechanism for a web server to tell a browser to bound or limit the web page that is being rendered in the browser. For example, well, we can go over a couple of examples. Like basically content security policy is a HTTP header, response header, that header name is content security policy, and then you have this simple grammar to describe the content security policy. It basically semicolon separated directive name and some value sequence. So for example, here is default source self and script source self code jQuery.com, which means that we allow any resource to be loaded only from itself, from the origin of the web page that was served, except scripts. For scripts, we want it to be loaded from self and code jQuery.com. I'll just go really quick over a simple example. We had to switch laptops, so I want to open this file to show you. No. Okay, I'm not that familiar in Portuguese. Tell me, oh, okay, Text Wrangler should work. Here, yeah. It's very simple HTML page. I hope you see it, yep. Well, maybe you don't. But content security policy can be delivered both as HTTP header or as a meta HTTP equiv tag, HTTP equiv value of meta tag. So in this case, we are just reading the HTML file from the disk, and we're setting content security policy to be script source self. And we don't have any scripts on this web page, and we'll try to load it. Here, we loaded the web page, there's nothing wrong. Now we can pretend that there's some injection on the web page, and we'll try to inject a script tag on the web page. So we're creating programmatically a script element, setting a text of that element, and trying to append that element to the body of the document. Here, we got a content security policy violation because browser didn't let that script to be executed because it's against content security policy that came with the page. And it actually is very verbose and tells you what to do. It tells the reason why the inline script was not executed, the alert one, and tells you what to do. You can either have unsafe inline keyword in the content security policy, or specify exact hash of the content that you are trying to inject. And obviously, attacker is not going to be able to do that because attacker would need to be able to modify the content security policy in order to inject that inline script. Or you need to specify a nonce. We'll come back to nonces later. Okay, back to the preview, I guess, yeah. Yeah, here's pretty much the same example, like you intend to load the cool.js script and the jQuery. And inline injection that runs some function will be blocked, and third-party script that is not whitelisted by content security policy because we don't have pet.com anywhere listed in the policy is not going to be loaded. So it's kind of cool, and that's all you need, right? Sort of. So content security policy level 1, version 1, which is implemented currently by Edge, I think, Edge browser only because they are always like slow in adopting modern standards. The policy implements, the content security policy can control these following resources. Connect source is controlling where XML HTTP requests can connect to, or like WebSockets, for example. Or frame source controls where frames can be loaded from. Images for images, fonts, media, objects is a cool thing to control where plugins can be loaded in the web page. And like normally you would say object source none, meaning you don't want your web page to load any Flash plugins or Java applets or anything like that. And script and style, and that's pretty much it. And if any of these directives are not explicitly in the policy, browser will use whatever is in the default source. It will default, for example, if you don't specify font source, it will default to the value of default source. We'll see examples. And in level 1, it was allowed to load content security policy only through HTTP headers. And yeah, those are some details that are not really interesting. And in CSP level 2, there were some expansion to the policy. You can now control, for example, where form can be submitted. So basically, if you have an injection and you have a web page with a form, which is supposed to submit the form to some URL, attacker will not be able to override the form submission URL, the action URL. Frame ancestors is a replacement for frame options header. So now you can specify who can frame your web page through frame ancestors directive. And it's like implemented properly, not like frame options where if you have, for example, 2 nested frames, then browser will ignore anything other than the first frame. Base URI allows you to define basically you hard code what is the base tag of your web page. The base tag is used to resolve all the relative URLs on the web page. And so on. There's nothing really like exciting. And there are some, I'm listing what are the changes. Yeah, for example, yeah, the very important change in CSP2 was they expanded the source expression to be not just the origin, like in the example we saw here that I'm saying codejQuery.com, which means anything from codejQuery.com, doesn't matter what the HTTP scheme is it HTTP or HTTPS, anything will be allowed to be loaded. But in HTTP2, you can now specify the path to the resource. You can lock down a specific resource. And we'll see why it's important later. Oh, and level 2 introduced nonces and hashes. Now you can specify a hash of a resource that you are expecting to receive from some third-party server or first-party server. We'll go back to what security policy violation is. And basically, these are directives that are supported in CSP3, which is the current state of content security policy. And yeah, if you wonder who is using content security policy, all the major guys are using it. Like Google's, any website served by Google is using content security policy very extensively. Like Gmail or Google Maps or anything pretty much. It's just, if you go to google.com and look at response headers, there might be no CSP at all because they will enable CSP after you authenticate to the website. Yeah, new directives introduced in level 3. This is the support, the can I use website. Basically, level 1 is supported by all the browsers except Opera Mini, which is not really a browser. Level 2 is supported by everyone except Internet Explorer, which is not a browser as well, I think, these days. And if you want details about content security policy, actually, I personally spent lots of time to make the specification be readable by a developer or by a penetration tester. And do not go to the official link. Official link is this W3C, W3.org TR. TR stands for technical review, I think. CSP, don't go there because even Anne, who is the maintainer of HTML specification, says the up-to-date specification is hosted at this URL, at W3C GitHub.io. Yeah, TR stands for trash in their slang. This is not really interesting. This is the timeline where certain directives were implemented. I think in Chrome, okay, worker source was implemented in 56. That's, I think, the freshest directive that was implemented by Chrome. 49 implemented require SRI for, and I actually implemented the spec and the directive in Chrome. It was really a challenging thing because like implementation took, I don't know, maybe 4 days, but then writing tests for Chrome took me like another 3 weeks. But there's nothing, like it's pretty easy, and everyone can start contributing to even Chrome, because there will be somebody who will review your PR, will guide you how to fix mistakes and how to write tests. So anyone basically can start contributing to open source browsers like Firefox or Chromium. Okay, now if you want CSP, what you should do, and like, do you really need it? You don't need CSP if it's completely static website, because there is nothing to protect from, and especially if static website doesn't store any state, like it doesn't make sense to use CSP there. Or if you have too many cross-site scriptings, you will be buried under violation reports that browsers will send you, and you won't be able to triage, like, you will be really overwhelmed by the reports that browsers from all over the world is going to send you. So start with something small, and we'll go over it. So as I mentioned, do not use, do not trust the whole origin. Like, do not trust code.jQuery.com, especially if you are not controlling it. Because jQuery can be compromised anytime, and you will not know about it. And the better idea is to, I think I have an example for this. Like if we open this, nope, it's not this one. Let's look. Strangler. Yeah, for example, a simple page where we say default source self, so any resource can be loaded from itself only, except, and scripts are also can be loaded from self. This is kind of redundant. But in content security policy, if you are not explicitly allowing inline scripts, they are forbidden. So here we have an inline script. We have a script tag where we have some JavaScript, which does something. Now, this will be forbidden. And here, like we have a violation which says browser tried to evaluate a JavaScript which is inlined, and content security policy does not let you evaluate it. Now, what you have to do one of these three things. Unsafe inline, which will allow any inline scripts, which probably you don't want, because any injection is going to appear in the browser as an inline script, and you won't be able to distinguish if it's something you want it to run or it's something malicious. Okay, let's go back to the presentation. It's a little messy. Yeah, here I'm saying that to whitelist the script that you wanted to whitelist, for example, you can use unsafe inline. And this validates something will work. But also there will be bypasses, because some attackers injected do evil function will also work. And also, for example, if you load something from code.jQuery.com, something that you trust, which is, say, jQuery version 2.2.4, an attacker can inject an external script tag, which will point again to code.jQuery.com because you whitelisted it, but he will load something vulnerable, like jQuery 1.6.2 is vulnerable to like reflection attacks. Or an attacker can inject something like this and it still will work. So that's a problem, so there must be a way to fix it, right? well, I'm not, we'll talk about problems first. So another problem is if you don't specify object source or default source in your policy, malicious or not malicious, I don't know, any kind of plugins will be allowed on the web page. So if there's an injection, an attacker can do something like this. Can inject an object, can inject a Flash plugin with allowed scripts, which is like known vector for another cross-site scripting. So something that's not exploitable right now might be exploitable. Also, you can whitelist schemes. For example, you can say that script source data or script source HTTPS. It's a cool thing to, for example, if you say HTTPS, that would mean to the browser that you only allow scripts to be loaded only from HTTPS URLs and not plain text. But for data, you cannot really specify what kind of content you expect within the data URL. So when you whitelist the data, that means an attacker can inject any kind of data URL, which can be, for example, something like this, something like a script do evil. Also, if you try to whitelist a JSONP endpoint, JSONP is it's a long story what JSONP is, but basically JSONP is a mechanism to JSONP will reflect back a function, reflect back and evaluate a function that you specify. For example, if you have something like, oops, if you have if you whitelist a JSONP endpoint, for example, at some CDN, which hosts some, for example, Angular, content security policy does not really control the arguments of the URL. So if you whitelisted cdn.com/JSONP and like you're using it actively in your web application, an attacker might figure that out and actually use it in a malicious way and basically send a function which will be where in HTTP response that function will be actually evaluated. So it's basically an attack vector. And content security policy cannot do anything about it because it does not really control the command line, the URL arguments. Like you cannot say, I only allow callback equals good. Any JSONP requests, any request to cdn.com/JSONP are going to be allowed. This is also sort of a compromise. So if you whitelist, for example, two origins, a good.com that you completely trust and some origin that you don't trust fully, but you trust a specific resource. For example, this partially trusted.com/trusted. If there is a redirect from good.com to partially trusted.com, actually the path is going to be ignored by the browser, by content security policy, the evaluator, and it's sort of a bypass. It will always work. Why is this happening? Because some guy figured out that you can use content security policy to exfiltrate the state of web application in the browser. For example, through content security policy violation reports, you can figure out, you can make somebody to load your web page, malicious web page, which will try to load something, your avatar, for example, from google.com. Now, if you are authenticated into google.com, your avatar will be served to your browser. If you are not authenticated, you will be redirected to some other URL. And you can craft your content security policy in such a way that, and serve that page to your victim, that by looking at content security policy reports, you can tell if somebody is authenticated to google.com or not. And in order to hide that information and like do not leak the privacy-related things, the compromise was made not to basically to ignore paths in redirected URLs. Yeah. Anyway, how to solve the, well, let's just take a look at some examples. For example, am I connected to the internet? I think no. Where is Wi-Fi? Yeah, can you please help me to connect? Oh, let's try. We can just look at some, yeah, it's not connected because I think Wi-Fi is not connected. No. Okay, then it doesn't matter. For example, I can just verbally tell you, for example, what happens on twitter.com. That's fine, guys, that's fine, yeah. For twitter.com, if you look at the policy that's served by twitter.com, there's like more than 200 whitelists in script source only. Like basically twitter.com is somebody set and configured a content security policy for twitter.com because there are so many corner cases where Twitter wants to execute scripts from third parties that list is like really huge. It's not maintainable. So it's because Twitter's policy was written before CSP2 was developed, and I guess they don't have resources to fix it. But here's an easy way to fix the problem, to avoid maintaining the whitelists. You can use nonce. What is nonce? It literally means number used once. And if your content security policy contains this, for example, you say script source nonce 123, browser will only evaluate JavaScript scripts that have nonce attribute with the same value that's in the header or like meta tag. So if there's an injection on the web page, attacker cannot guess what this nonce has to be when he crafts a script tag. And it's pretty effective way to write simple content security policies that don't need maintenance. And yeah, nonce attributes can be applied both to inline and third-party scripts. So here's like we have a third-party script that loads jQuery.com. So attacker, we don't use whitelists in the content security policy. And if attacker manages to find an injection, even if he tries to inject a script tag with source equals jQuery 162, which is vulnerable, he won't be able to tell what is the nonce, like at runtime. And the same thing with inline scripts. And it also fixes the JSONP bypasses. Like if you whitelisted a JSONP endpoint, well, no, you don't whitelist the JSONP endpoints anymore. You just specify nonce in the script that uses JSONP endpoint. So attacker won't be able to inject similar script that will be allowed by the browser. But there's a little problem. If you are using some JavaScript library or your actual code is creating dynamic scripts, for example, it does document create element script and then like does something with that script, that script is not going to be evaluated because you don't have the nonce. You can actually specify nonce by like doing el.nonce equals the actual value, but the framework that you are using, for example, AngularJS or jQuery, should be aware of the nonces, and basically every component in the chain should be aware what nonce is, and that nonce should be added before you try to append child the script to the DOM. So how to fix it? Actually, I thought I had another slide, but yeah, whatever. These two guys from Google who are actually the like security engineers, they are making sure that Google web apps are behaving in secure manner, came up with this keyword called strict dynamic. So the idea is that you have very simple content security policy, no matter how complex your website is. All you do is you have this script source nonce and strict dynamic keyword. What this means is that your web page trusts a script which has this nonce, and whatever that script is doing, it's trusted. It's like basically trust propagation. So you can write a script that would load another script from somewhere else, or like would dynamically construct other scripts. And that would mean if strict dynamic is there, browser is going to allow it. So this is good when when resources that the parent script is loading are being loaded from trusted sources. Like in case of Google, likely any scripts that they use in their web applications are still coming from Google entities. Like it's from some CDN that's controlled by Google, or some other CDN that's not controlled by Google, but they have some kind of agreement that they can trust that CDN. So it's kind of safe. But if you, for guys like us, I cannot trust jQuery.com, and like I cannot, well, even if I write a JavaScript that loads other scripts from, for example, jQuery.com, you don't know what the jQuery.com script is doing, actually. Like maybe it's compromised and there's some attack happened and now they are doing something really bad. And like using strict dynamic is kind of risky there. So what you can do, you can log down to what you actually expect from jQuery.com, for example. You can specify a hash of the content that comes back from jQuery.com. I think I have an example, but it'd be messy to set it up. Let's look. Maybe it'd be more like visually. Yeah, I don't have internet connection, so we're not going to see anything useful. But that's fine, that's fine. It's not really like very important, so it's fine. Thank you. No. Yeah, sort of using strict dynamic is going to solve any problem that you had with whitelists or with those bypasses where you don't specify path and somebody loads a script from the same origin that you trusted, but something malicious. And you also don't have problems with inline scripts because it's fine. The way strict dynamic works, like for example, if we serve this policy to, like you would ask, what would happen if you serve this policy to a browser that doesn't know what strict dynamic is so far? For example, Safari does not know what strict dynamic is because they only implement CSP level 2. Or IE 11 doesn't know about strict dynamic, and it doesn't know what nonce is. So the way the grammar is designed for this, we can call it a language, is if it doesn't know what a keyword is, it's just going to ignore it. So this policy is going to be viewed by a browser that implements CSP level 3, which will be like modern Chrome or Firefox. It will be treated as this. Like if Chrome sees strict dynamic, it's going to ignore unsafe inline, which whitelists any inline scripts. If browser is level 2 and doesn't know what strict dynamic is, but it knows what nonce is, it's just going to load scripts that have this nonce. And it's not going to break. And oh yeah, and there is in the specification, specification says that if you see nonce, a specification level 2 says if you see nonce, ignore unsafe inline. Do not like just ignore this unsafe inline. Do not whitelist all the inline scripts. Just whitelist those that are that contain this nonce. And really old browser is going to see this, is going to parse this content security policy as this. It doesn't know what strict dynamic is. It doesn't know what nonce is. So it's going to just consume what it knows about, which is unsafe inline. So it's going to whitelist unsafe inline all the inline scripts, which is bad, but it's better than not controlling inline scripts at all. Okay, what's not controlled by CSP? Surprisingly, any communication that browser does to outside world, or like when it loads resources, everything is controlled by CSP these days, except WebRTC. It's just a technical limitation because everything in modern browsers go through fetch API. Like when you load styles, for example, or when you load images or fonts, HTML specification actually describes the algorithms how browsers are supposed to implement the loading of those resources, and it goes through an API called fetch, and CSP is being applied at pre-request stage of that fetch API, except WebRTC. It's just technical limitation because WebRTC is not implemented through fetch yet, and turned out it's a big problem. Like, there are lots of issues on GitHub reported about it, where ad block developers, for example, they don't see WebRTC connections happening in the wild because like ad block is a browser extension, and browser extension can only see HTTP connections before they happened. And they don't see WebRTC, and even if you have content security policy specified, content security policy like mechanism implementation in the browser is not going to see WebRTC as well. So right now, ad networks, for example, are using WebRTC to pull in ad content into the web page, even if some browser extension does not let that happen or tries to prevent it, or if you have content security policy that prevents, that locks down ads to be loaded from specific endpoints. So it's a problem, and like hopefully it will be fixed soon, but so far it's not fixed. It's the only way to bypass CSP right now. Like, what can you do to adopt CSP? Like, as you see in these really simple examples, all you need to do to start doing things is you can start with meta tag. You just have this meta tag with HTTP equiv content security policy and content, for example, default source self. This would at least make sure that scripts are coming from whatever from the locations that you intended them to become from. This can be important in bigger corporations where, for example, you have a policy where all your dependencies of your web page should come from your the websites that you control. If you are hosting jQuery.com, jQuery, a specific version of jQuery on your own in the corporate network, you still don't know what the jQuery.com is going to do. Like maybe there will be some like corner case where it sees if it's Opera, it would load some extra resources from somewhere else. And like you either have to do static or dynamic analysis of the jQuery.com before hosting it in your internal network, or you can just use CSP and see if using the jQuery.com that you hosted is going to create any content security policy violations, and then you can like adjust either your policy or just notify the guys who are responsible for hosting the jQuery.com that it still makes external requests, so guys fix it. Yeah, content security policy has a very useful mode where you, instead of saying content security policy as HTTP header or meta tag header, you can say content security policy report only. It will behave exactly like I described, but instead of enforcing the content security policy, it is just gonna generate reports and still allow those scripts from places that you don't want to be loaded. It's still gonna allow those things. It will just notify you as within the report. We'll see what report looks like a little later. Yeah, make sure your policy works in like older browsers. It's like really easy. Like Chrome did really good job at suggesting what to do. Like they even, I don't know, what do I do on this web page? But here, yeah, I'm injecting some inline script, right? Chrome even calculated the hash that this SHA-256 that corresponds to the content of the script that I want to inject. So you can just like, copy this value here and paste it in your content security policy. I'll skip unsafe hashed attributes because it's really, like I think it's going to be removed from the specification because there are some arguments. But basically unsafe hashed attributes right now I think it's implemented in Chrome. You can specify a hash of event handlers, like in, and like whitelist specific event handlers that appear in the HTML. Like for example, you have some button and you have onClick and you have some script that is of the value of the onClick attribute, and you can, through unsafe hashed attributes, you can whitelist specifically those handlers. But yeah, looks like it's going to be removed. So for deployment, you should really start with report only and see what are the reports that coming from the wild, from the field, and adjust your policy, which should be specified as report only at least like first week, and try to do A/B testing, like send something with CSP and without CSP, or like with two different CSPs, and try to figure out which one is better, which one serves your needs. Reports. So in content security policy, there is a directive called report URI, where you can specify the URL where you want the browser to send the violations to. And what is the violation? Violation is basically a JSON. Violation is a post request with a JSON blob in the body. And the JSON blob, well, this is the description of the web IDL description of the object that report contains, but this is actual example. So it's a JSON blob which says here, the report was generated at this origin while the web page was at this origin. This is an example. The refer is empty, for example. What was blocked? An inline script, which is good. Which directive was violated? Script source. I don't remember what effective directive is. It will send you the actual, the original policy, because there might be browser extensions that would modify the content security policy before it's being parsed. So from this field, you can tell if some browser extension actually modified the content security policy before it was parsed. This field, sample, was added really recently by these two Google guys, Michel and Lucas. And now, content security policy violation also contains a snippet, first 256 bytes of the script that violated the policy. Like in my case, I tried to inject alert 1, and I actually know what happened. Because previously, it was really hard to tell what caused the violation. Like without this field, this report is quite useless, because yeah, you know there was violation somewhere, but what was violated and how it was violated, you didn't know. And people were just ignoring their reports, because you cannot tell much by looking at this without this sample. And yeah, version 3 now contains the sample property, which hints you what was actually how violation occurred. Oh, and the disposition tells you if it's in enforcement mode, if policy is in enforcement mode, or if it was report only mode. It will just basically say report only instead of enforce. Unfortunately, still, for example, I have a web app that uses CSP, and I receive violations, I don't know, every day. And there's a lot of noise caused by browser extensions. Like, for example, all kinds of ad blockers will try to block something on your web page, and that would cause a content security policy violation. Or if there's an extension that changes, you have an extension that changes default styles of the web page, that will try to inject some custom style that you didn't want to be injected, and you actually enforce it through your content security policy, and that will cause a content security policy violation. And you receive so many reports every day that you might miss actual attack happening on your website. So you need to really have a good filtering mechanism. I don't know, maybe you want to ignore violations caused by style sources or image sources, because you don't really care if there was image injection on your web page. So, and unfortunately, there's no the ready solutions that would let you easily filter content security policy violations. There is I think on the next page, no, I don't have it. Well, on my last slide, I have a resources listed, and for example, there's a paid service called CSP report.io, I think. and you can point your your report URI to that service, and they would do some aggregation and do some like analysis of the violations, but I don't think it's good enough. And there's room for improvement, and I'm still waiting for somebody to develop something nice that would analyze the content security policy violations. Best practices, yeah, try to avoid whitelists. Because we know that they are bypassable, and like strict dynamic is pretty good solution for almost everything. Always have default source, because you don't want, if you don't have default source and, for example, don't have a specific resource directive, like you don't have font source specified, that means fonts are allowed from anywhere. Browser is not going to enforce anything. Or, for example, if you don't have default source and don't have object source, objects or plugins will be allowed from anywhere. So always have default source in your policy. And like default source none will by default restrict anything. Nothing is allowed to be loaded if you have default source none. Use nonces wherever possible, at least with your scripts and styles, or maybe just scripts. And consider using strict dynamic. Do not use unsafe eval. Unsafe eval is another keyword in content security policy that will allow eval to happen on the web page. And by default, if unsafe eval is not specified, no script evaluations are allowed in the JavaScript context. Here are some statistics that I ran on Alexa Top 1 Million. Like in September 2016 compared to June 2017, there are much less policies found with report-only mode, which is probably good because people probably switched from report-only to like enforcement mode. Still, adoption level is pretty low. From 1 million websites, only 15,000 are using in 2017. But like I scanned without authenticating into the website. So maybe they, like Facebook, for example, serves CSP after authentication. So I'm not counting that. Lots of people compared, like if you compare September 2016 with June 17, much more people are started using reports and started collecting reports. This doesn't probably mean anything. It's just like statistics. Which directives are most popular? Well, of course, script source is most popular because injections are exploitable mostly through through JavaScripts and not through, say, images or fonts or I don't know, media source. Makes sense. Like it grows steadily, but still not fast enough. Oh, I also developed a Java library which deals with content security policy at runtime. Basically, you can pass a content security policy to my library, and it will like analyze it and say if there's like some critical errors or like well, I have 3 levels of reports: warnings, errors, and information. And I think on the next slide it's more detailed. January 2017 compared to June 2017, people were using, I don't know, some really outdated directive names that are not supported by any browser anymore. They were using those directive names much more frequently in the beginning of the year than in the middle of the year. Or they have some typos in the value part of the CSP, like they have script source, which is like valid, but then they have some typos or some illegal characters that are basically making browser to ignore the whole directive. Like 19% of policies actually still contain errors in the source expression, or yeah, some errors in the directive name itself. Or some people use non-ASCII characters, and you cannot use any non-ASCII character in any HTTP header, and CSP is not an exception. If you want to have something non-ASCII, you just have to URL encode it as you would do in URL. The delimiters between CSP directives semicolon. And some people just make mistakes and put commas there, and you're just gonna like stop parsing the policy right after the comma, and people might not realize it, and they would think they're protecting their website, but in fact, browser is just gonna ignore whatever is after the comma. And unfortunately, by the way, Chrome or like Firefox is not gonna warn you about it. And yeah, these are resources. This CSP evaluator is by Google. It's a pretty good thing to like evaluate your policy and get suggestions what you have to do with your policy. This is the library that I developed. It's used by W3C's HTML validator. Official W3C HTML validator. It's used by Zap proxy, for example. It's used by some commercial websites. ReportURI.io is the service, paid service that would collect your violations and then like analyze it and like generate nice graphs or maybe do some statistical analysis, and that's it, I think. So if you have any questions or suggestions or like explanation why you guys are still not using CSP, I'll be happy to discuss it. Sure.
When the server tells the browser what are the policies, can an attacker intercept this message and change it or not?
Of course, they totally can, but CSP is not going to help you because attacker can just inject whatever JavaScript he wants to be evaluated on the web page directly without even maybe touching CSP. But the idea is, it makes sense to use CSP with HTTPS and like really secure HTTPS. Like you shouldn't really. Yeah, assumption is that you should always use HTTPS these days. Yeah, and Chrome and Firefox are doing really good job deprecating websites that allow plain text communications. And CSP is also like have a couple of directives that enforces it. There's a upgrading secure request directive that basically instructs a browser, even if your web page that you served contains a plain text link to something, like for example, image that has HTTP scheme, browser will ignore that HTTP if there is an upgrading secure request directive in CSP. Browser will ignore HTTP and upgrade HTTP to HTTPS blindly. Or there is another directive called block mixed content. It will not let, it will not let plain text communications happen within the web page if you have that directive. It will basically enforce, and so like attacks like HTTPS downgrade will not work on the web page. And that's only enforceable by CSP these days. I think that's it then. Thank you very much.